Hey guys, this is Mitch with Fine Point CGI, and today we're going to talk about what UML is. We're also going to talk about how to use UML to help structure your code and how to design good design paradigms for your game. So how to structure your game correctly. So that's what I have in store for you guys today. So let's go ahead and get started. Okay, so the first thing that we need to talk about is what is UML? And UML is a unified language for specifying, visualizing, constructing, and documenting software. Now, this was created back in the 1997, I believe, and it's considered a unified way for us to talk to each other as software developers. So it doesn't matter what language you know or what tool you're using, we can all talk to each other with UML. Now, one of the big goals of UML is that a picture is worth 1,000 words. Okay. The idea is that you're going to draw a picture out to explain what kind of tool you're trying to build is. And the nice thing about UML is it's really hard to explain a design or to explain a software structure without using some kind of picture to explain it. So that's kind of what UML came to be. It was used to explain software to a non-software developer. You could say, well, it goes here and it does this, and then it goes over here and it does this, right? And that's the idea behind UML. Now, we're not going to go into crazy amounts of detail with UML because it would literally require a 17-hour tutorial series. And I can definitely go in and give you guys all the detail you want. But let me just give you a spattering of kind of what UML is, and we can go from there. So what I have up on the screen here is what's called Draw.io or app.diagram.net or diagrams.net. And I have a link to it in the description below if you guys want to follow along. Now, the first thing that's going to happen when you pop up Draw.io is it's going to say, hey, where would you like to save your diagrams to? I'm not really worried about that, so I'm going to say decide later. And it should pop up and ask you what kind of template you want to start with. And in my case, I'm not going to start with anything. I'm just going to start with a blank diagram. So we're going to go ahead and just click create, and we'll go from there. Okay, so this is Draw.io. Now, Draw.io is a UML tool that allows you to literally go out and model all of the stuff that you need for your project. So normally what I like to do when I design things is I like to start from the most basic elements and then I distill it down into its details. So, for example, let's start off with a basic game design. So, let's say we're building a 2D platformer. Actually, since I have my 2D platformer series, I might as well use that as an example, right? So we can design that system, and then you guys can get a clearer idea of how that's structured, and then we can kind of go into what UML is. So the way the application works, we have a little box here, a little rounded rectangle. We're going to drag that into here, and then we will double click on it and type Game Manager. And our Game Manager is the thing that controls everything, right? It's a public static object, and everything falls through it. So I'm going to go ahead and click on that, and I'm going to make it blue to say this is a public static object. There's only one, and that's that one. And then I'm going to drag in another rectangle, and I'm going to double click on it. I'm going to call it Character Controller. And I'm also going to make that blue because that is a public static object. And what we can do is we can click on our Game Manager and go ahead, and you can see this little arrow here. If we click and we drag this down into our character controller, that's going to make a link to our character controller. So our character controller is also going to link back. So we'll go ahead and do that. So we'll put that in. And I'm going to pull this over by grabbing onto this little circular icon here. I'll pull this over and let go. And that's going to make it so that they're both connected to each other. So they communicate to each other, right? So what other kind of controllers do we have in this game that we have, right? And in my case, I have a user interface controller here. And I'm going to go ahead and drag my game manager down and my user interface controller back up to my game manager. And that will allow me to have a control kind of like this. So you can see I did not color this one. This one we're not going to color blue. And the reason why is this is not a static object. It's something that can be destroyed and remade if we need to. Let's say we need to reset our UI, right? Now you can see here that if our character controller wants to talk to our interface controller, it can't. It has to go through our game manager because of the way that we have our lines set up. So we'll keep that in mind while we're coding, right? Now, what other different controllers would we have? Well, we would have a spell controller, right? If the character can cast magic. So we'll say spell controller here. Actually, we'll call it magic maybe. Because it might not be spells, it might just be regular magic. So we'll say magic controller. We'll go ahead and put that up here. And we'll go ahead and drag that through here. So what that means is if you want to talk to this, you're going to need to go through the game manager to get a reference to this controller. So if character wants to do any kind of magic, you need to say, hey, game manager, can I have a reference to this object? Okay, now object, I'm going to work on you, right? Now, what else does our magic, what can our magic controller control? Well, it can control spells, right? So we'll go ahead and put this underneath here and we'll put a line down to it and say spells. So we'll go ahead and make a double connection there. And you can see if our user interface wants to get what spell we have equipped, we can actually just go straight through our magic controller or straight through our game manager to our magic controller and then to our spells. So this is what UML allows us to do. It allows us to segment our code so that way we can design our code properly. So what else can we do? Well, we can also say, okay, game manager, I need you to pass my save / load manager, let's say. And we'll pass that up to our game manager as well. So we'll put this over here. There we go. So when we want to save, we will go through our game manager to our save and load manager. There's going to be no other saving code inside of any of these objects. They will just be in our save load manager, right? And we can have our AI manager perhaps. And we'll pass that in here as well. Because that's stuff that can get destroyed. Again, we can destroy any of these things but the character controller, because obviously if the character controller is dead, then the whole game is basically gone, right? So that's the basics of creating systems, right, inside of UML. So now that we have like basic structure down of kind of how we'd want our stuff to work, let's talk about object orientation. So what we can do is we can come into our UML section here, down here on the bottom here. We can click on UML and you can see that they have all these different UML stuff. And I'm not going to go through all of it because there's a lot here. But if we kind of just pan out of the way here, so that way that stuff's hidden, we can actually come in here and drag in objects, interfaces, classes, and class names, or class type 2 class, I should say. So what we could do is we could say, okay, class name here, we could double click on it and say character, let's say. And we'll say our field is a character's name, let's say, and we'll say that's a string. And then we can come in here and we can say health, because every character has a health. And we'll say that's an integer. And then we can double click on this and say speed, and we'll make that int as well. And then I need additional stuff here. So I'm going to click on my character. I'm going to go up here and I'm going to go ahead and add in a couple additional ones. I don't know, a few of them. And we'll say name, health, speed, let's say velocity, assuming that they're going to move, and we'll make that a vector 2. What else would a character need? I think that we'll call that good. So we'll go ahead and get rid of the other two. So we'll pop those two off. All right, so we got our character here. And what we can do is we can go ahead and drag in another class here, okay? And we can say slime here. And that's going to be our slime enemy character. And our slime enemy character inherits from our character class, right? So we can actually click this and drag this down. And what inheritance means, if you don't know, is inheritance means it gets all the properties of this character object here. So that means that the slime by default will have a name, it'll have health, it'll have speed, and it'll have velocity. Now, what are some other things that a slime enemy might need? We could say alerted. We could say damage. We'll make that an integer. And I think that's all we really need. So we'll go ahead and pop that one off. But then also we can kind of drag in another one and say player. What would the player have? Things like mana, perhaps. Since we decided that there's a magic system here, I imagine that they would have mana. What else could they have? Money, let's say. So let me see, quest items maybe. And we'll make that a quest item type. And you can see that, well, we have a quest item here. So let's drag this out because it's a quest item. And let's go ahead and drag in another class. What's considered a quest item? Well, a quest item could be which NPC gave it to you. So NPC, let's say, which quest it's a part of. And we'll say NPC is an NPC type. And you can kind of see how this gets pretty messy pretty quick. And we could say picked up. We'll make that a bool. But you can see how this can kind of get messy pretty quick because now that I just dragged this out, right? But I also have quest, right? So now I've got to make one for quests. So we can drag this here. We can say quest and we can say NPC. So which NPC gave it to him. And we can say fulfilled, let's say. So complete. And we can maybe say, reward. And that reward could be an integer, let's say. Let's say it's a reward amount. So they give them money or something like that. And we can kind of drag this out to our quest object here. And you can see that we need to create an NPC because this one also has NPC and this one has NPC. So let's drag out a class name and do NPC. And we'll just put quest. And actually, I wonder if we need NPC in here. Since this is going to hold a reference to a quest, I don't know if we need it. Well, actually, it would be a list of quests. So this would be a list of quests, I imagine. So we could do list quest. And that's going to relate to quests. So we'll drag this out. And actually, I don't know if we need NPC in here, so let's get rid of that. There we go. And instead, we don't need quest. Well, yeah, I think that'll be fine. And we'll say if they sell anything, let's say they might be a merchant. Actually, you know what? No, I don't think I would do that because I would just do merchant. So then, since NPC is a character, we can make that link. So let's go ahead and make that link. So we'll link those together like that. And you can kind of see how this works. And since player comes from character, we'll drag that in there as well. And you can kind of see how we can structure our game before we start building out our game. And, of course, you could come down here and say merchant, let's say. And they have, money, which is an integer. And then they have items. So that's a list of items. And we'll say that that's all they have. And an NPC could be a merchant, so we can drag that down. And that's kind of the power of UML, is it allows you to design out how you want your stuff to structure, and it makes things easy, because at a glance, I could tell you, oh, well, you know, a player will have a quest item that links to a quest, and the NPC will hold on to that, a list of quests, right? And a character is also, or a character has health and all of this stuff. So it gives you a lot of flexibility and a lot of really cool inherited stuff that you can do that will really help organize your code. Now, the other major thing in UML is what's called a state machine. And basically a state machine is you saying, I'm doing a thing, and you're reacting to that thing, if that makes sense. So for instance, if I come over here and I say, let's go ahead and model out our slime. So if I come over here, I scroll up and I create a small box here, and I say idle, and we will go ahead and add in a black circle here. Let's see if I can find one. Usually use a black circle, but I don't think Draw.io straight off hand has a black start, so we'll just use one of these little small guys. So we'll say on start, so when the application starts, the slime is going to go into idle mode, right? And then from there, he will transition into movement mode, which is where he will go and walk, right? So we'll say move right. There, we'll say he moves to the right first. And then we're going to put a diamond here. And a diamond is considered a decision block. So it's kind of like, did something happen? So I would say, is player detected? Okay. And if he's not detected, then we're going to run another check here. And we're going to say, am I falling off on edge? And these are all questions, because these are decision-making blocks, if that makes sense. And if that's a no, then what I'm going to do is I'm going to check, am I hitting a wall? All right. And if that's a no, we're going to fall back to our move right, because he's going to be able to continue moving right. We haven't seen a player, nothing's going on, we're going to move to the right. Simple enough, right? Now, I can just drag this over. Is player detected? Am I falling off an edge? And am I hitting a wall? Now, if I am falling off an edge, what am I going to do? Well, I would move to the right, or move to the left, I'm sorry. Right? So it goes to a different state. It's now moving to the left. If player is detected, I am going to go after the player. Makes sense, right? If I am hitting a wall, I am going to move to the left. And once all of that's done, then I am going to end. So now I will be in my end state. So I'll drag this down, and we'll drag this down. Simple enough, right? So that's basically the basics of UML in that sense, at least. Now, you can see our little state machine here. So we start off idle, we move into moving right. Then we check if the player is detected. Am I falling off the edge, or am I hitting a wall? And if any of that's not true, then it's going to go right back to move right. If any of this is true, it's going to either move left or attack the player. The last part that we can talk about is actually structuring our code using this system. So, for instance, let's say that we are developing, let's look at our save and load manager. So if we're developing this little section of our code, we can really break it down into a few states, right? We can really break it down into our save and our load, right? So if we just kind of drag these in here and kind of pull this down like so, And we could pull this one down like so. And then we could say, for instance, save and load. And we can really break these down into an actual functional diagram. So if we come over here, let's say, and we grab in a start node here. So we drag this in, and I'm going to make this smaller because I like my nodes to be tiny. And then we can grab an end. We can put this in, and we can kind of bring this down here, and we can say, okay, first it's going to take in some data, right? So we're going to take in. So we'll say take in data to save, we'll say. And then what we're going to do is we'll do a little bit of validation here. So we'll validate that the data is correct. And then we'll say, is data correct? If it is correct, so we'll bring down a thing here. We will go ahead and save that data. Actually, first we need to convert the data to JSON. Then we need to go ahead and write the data to file. So we'll write data to file. And then we will go ahead and close file. All right, now if we put these together like this, this is the flow of our diagram. This is how the things are all going to work, right? We can kind of drag this down, and then drag this down like so. And then we can say, okay, this is how I'd like things to flow. Is the data correct? If it's not correct, then we need to throw data not valid and return, right? So we're going to go ahead and return. So we'll go, is data correct? No, throw data not valid, and then come over here. And we can actually click on this. If we double click here and we start typing, we can say no. And here we can say yes. So that way we know what's going on, right? Data is not correct, throw data not valid, and then return. Is data correct? Yes. Then convert it to JSON, write it, and close the file. Now, something that we're not checking, judging by what I've structured here, is we're not checking if there's data already in the file, right? So we need to check for that. So does file exist? So we'll need to check for that. So let's go ahead and pull this off and put it to here. Instead, does file exist? If it doesn't exist, we're going to need to create the file, right? So no, create the file, right? And then we can convert the data to JSON. But if the file does not or it does currently exist, then we're going to need to go ahead and delete the data inside of the file. So clear data in file. Then we can drag this down. We can have it connect like that. And then we can do the same thing here. Drag this down and connect. And you can see basically this is how UML operates on a basic level. I'm not going to get into use cases and things like that. I don't think we need to do that. But this is a really simple way to have a picture of how your code works. One of the things you guys asked me was, what's a really good way to make sure that you pre-plan all of your code? Well, that's what basically UML is for. It allows you to create a roadmap of where you're going to go before you go. So one of the people that taught me UML a long time ago told me that UML is basically like Google Maps. You can say, I'm going to drive to a location without a map. And you're going to drive and suddenly you're going to hit a roadblock and say, oh, well, I'm going to go around it and kind of, drive around this roadblock. And then you kind of doing so, you hit another roadblock. So then you kind of drive down a little bit further. And then finally you get back on the path and then you kind of get on another roadblock and go off path again. And that's basically what happens if you don't plan out your code beforehand, is you just kind of drive down and then you hit all these roadblocks. And it's a very common mistake that a lot of developers make, including myself. Even with my 7 years of experience, I still make a lot of mistakes with my code without pre-planning. So it's just something to keep in mind, is that you want to pre-plan your code as much as humanly possible. But that's basically the gist of how this works. You can do things like class diagrams to help determine what things inherit from what things. You can go ahead and make state machines and designs like this, or in this case, state machines like this, which help design out your code and help you figure out how you're going to design things. And you can also do things like designing out specific functions or specific functional requirements that your game needs. And this is stuff that's really going to help you guys in the future. So I really suggest that you guys learn it, because in the industry, this is what people do. We don't just code without thinking things through beforehand. But that's all I have for you guys today. So if you like this video, hit that like button. Hey, if you dislike this video, go ahead and hit that dislike button, because I am here to make content for you guys. As always, this video was a viewer suggested video. So if you guys have any suggestions, go ahead and throw them in the comments below, and I'll be more than happy to go ahead and take a look at them, because I am here to make content for you guys, and I want to make stuff that you guys enjoy. And hey, if you guys have any questions about UML, or you want to tell me that I don't know what I'm doing or anything like that, go ahead and throw a comment below, and I'll be more than happy to respond to you and talk to you about it and help you through it. Or hey, if you want to take more of a short form discussion, you can go ahead and jump on the Discord. Link is in the description below. As always, I am always happy to talk to you guys. We're all part of a big family, so I'm here for you guys. But that is all I have for you guys today. So thank you so much again for watching, and I will see you all next time. Thanks.